All right, so we're going to talk about synthetic division. When we have polynomial functions, we can divide smaller polynomial functions into them to find zeros, to find roots. If you think about it, if I said, here's a number 27, find the factors of this. Well, what you would do is you would start by dividing a number into it, 3. And 27 divided by 3 is 9. And then you take that 9 and you break it down into smaller factors. That's exactly what we're going to do with polynomial functions. Now, you may have looked at polynomial long division before. We're not doing that. This is synthetic division. So with synthetic division, it's all about the coefficients. It's all about the numbers. You can only synthetically divide when you are dividing by a binomial, and it's just a single x to the first and one constant. So on the outside, we're going to put the 0. Now, if this factor is x minus 3, what's the 0? 3. Again, because x minus 3 is equal to 0, so if we solve for x, that means that x is equal to 3. Now, inside this little box, we're going to put the coefficients. So this is going to be 1x to the third, negative 2x squared, and this is important, 0x and negative 9. We need a placeholder here. This is 0x to the first. All of your degrees must be present. So if we have a 3, if we have a degree 3, then we must have exponents 2, 1 as well. If I have degree 7, I have to have exponents 6, 7, 5, 4, 3, 2, 1. So here, because there is no x, I have to put 0 as a placeholder. And so what we do is we bring down the 1 first and put it outside. And then we do 3 times 1, which is 3. And we bring that up here. And all of these columns we add. So negative 2 plus 3 is 1. We multiply by the outside again, so 3 times 1 is 3. We add, so this is 3 plus 0, which is 3. 3 times 3 is 9, and negative 9 plus 9 is 0. This last value here, that's going to be the remainder. And for the rest of these, we start with the one less degree. So here the degree is x to the third. So what we're going to have is x squared plus x plus 3. X squared, 1x plus 3. And that's our answer. So we want to look at a couple more examples here. So I'm going to start by drawing this little bar. On the outside, if x plus 2 is my factor, then negative 2 is the 0. I have degree 3 and exponents 2 and 1, so I'm set. I'm going to put 5, 8, negative 1, and 6. And I'm going to start by bringing down the 5, and then diagonally multiply and add. So negative 2 times 5 is negative 10, plus the 8 is negative 2. Times negative 2 is positive 4, plus the negative 1 is positive 3. Times the negative 2 is negative 6, and for this example, I have another remainder of 0. So my answer is going to be 5x squared minus 2x plus 3. Now this one looks more challenging than it actually is. On the outside, if x plus 1 is my factor, then negative 1 is my 0. And I have 1x to the fourth, 0x to the third, 0x squared, 0x, and finally a negative 1 as my constant. Bring down the 1. I multiply to get negative 1. Add to get negative 1. Multiply by negative 1 to get a positive 1. Add to get positive 1. Multiply to get negative 1. Add to get negative 1. Multiply, and again, the remainder of 0. So this quotient will be x to the third minus x squared plus x minus 1. And here we have some other examples. So I would recommend you go through these now. Pause the video and then see what you can do. And I will go through them. So pause it and then try them. All right, so here we go. So we have 4 as our 0. Now it's nice, it tells us that the root is 0, so this factor would be an x minus 4. And then our coefficients would be a 1, -2, a 1, and finally a 0. The 0 is for the constant. So I bring down the 1, and I'm going to multiply to get a 4, 2, multiply to get 8, add to get a 9, add to get 36. So my answer here would be x squared plus 2x plus 9, and I'm going to have plus 36 over what I was dividing by, and because I was dividing by x minus 4, I get 36 over x minus 4. Because the root was 4, the factor was x minus 4. That's what I was dividing by. So that's an example of when we do have a remainder. Whatever we were dividing by is in the denominator, and the remainder is in the numerator. And next we have this. So we have the root of 4. And then we have 1, -4, -2, and 8. So we're going to bring this 1 down. 4 to get 0, 0, -2, -8, 0. So luckily here we don't have a remainder. We don't have to worry about that. So we're just going to have x squared plus 0x minus 2. We don't need to write that plus 0x because we understand if we don't write it there, we know we have 0 x's. For number 3, we put the 1 outside, and then we have 1x to the third, -6x squared, 5x, and 0 as our constant. So bring down the 1, multiply to get 1, add to get -5, multiply to get -5, 0, 0, 0. So what I end up with here is I get x squared minus 5x. No constant, no remainder. And finally for number 4, I put a -2 on the outside. I have 1, -5, -4, 20. 1 times -2 is -2. Gives me -7. I add these together to get a -9. Sorry, I multiply them. I multiply these together to get a positive 14. And I add these to get a positive 10. And that gives me a -20, which gives me a 0. So down here, I'm going to have x squared minus 7x plus 10 with no remainder gives me this answer. So as you look through these, hopefully this gives you a better idea of what to expect and what you need to do. Make sure that you put your placeholders in. Make sure that you remember what's your 0, what you're dividing by, and also watch out for how to write the remainder.